All right, this is the extra 5.1 to 5.3 review that was given out in class. And so I'm going to go through these kind of quickly. Maybe not. We'll see. All right, so it says use identities, and basically that means just use, I don't know what they want us to do in terms of use identities. A lot of people, I think, drew triangles, which you could do. I'm going to do without triangles just because we have cosine, and cosine is going to be adjacent over hypotenuse, so we know what one side is. We're just looking for sine and secant. Well, secant's really easy because secant's reciprocal, so secant theta is negative 6 over 5. So boom, that's done. To find sine, we know that sine squared theta, that's what it wants us to do. Sine squared theta plus cosine squared theta equals 1. I think what they wanted you to do in terms of using identities is to come in here and go, okay, so we're going to go sine squared theta equals this angle, which is going to be plus, so negative 5, 6 squared equals 1. And so this is going to be some other, is that what it wants us to do? 5, 6, yeah, I think that's what it's thinking of. So if I did this, and I went 25, 36, and this is 36, 36, and then I went theta squared equals, 27, was that 11, 36, so theta equals plus or minus the square root of 11 over 36. So that's going to be theta equals, and it's negative since sine is negative, so it's negative root 11 over 6. And since it's the sine of it, then this is sine, then we know this is the, we know that's the opposite side. We know this is a hypotenuse. So secant, or sine would be, sine theta would be opposite, which is negative root 11 over 6. It's basically, this is it. Okay. So I didn't draw a triangle. If you drew a triangle to do it, that's fine, but you can also do it using Pythagorean. We would do the, see over here we have cotangent theta over 5, 7. So we need to, we need to find out what the hypotenuse is, right? Because this is adjacent over opposite. So I'm going to go 5 squared plus 7 squared equals c squared. 25 plus 49 equals c squared. So c squared equals 4 carry the 1, 74. So c equals the square root of 74. Let's see, it's going to be, well, that's going to have to be positive. If secant is less than 0, so secant is wherever cosine would be 0, which would be anywhere here and here, right? Which means that, but our cotangent is positive, so that means we have to be in this quadrant because these were negative and they become positive. Hopefully that makes sense. So let's see, cosine would be 5, negative 5 over square root of 74, or negative 5 root 74 over 74. And then sine would be 7, negative 7 over root 74, or negative 7 root 74 over 74. So that's just, we're just using Pythagorean. But if you drew a triangle, that's great. Just make sure in the right quadrant. And the main thing is make sure you have these signs correct. That's been our biggest problem, right? The last test. Okay, let's get to the verifying problems. We could pick either side. Pick a side, pick a side. Let's see, since I'm going to do the left side. Oops. And since these are in terms of cotangent, tangent, let's go with, let's see. Cosecant squared x equals cotangent squared x plus 1. So let's do that substitution. We're going to put this in for here. Cotangent squared x plus 1 minus secant squared x equals cotangent squared x minus tangent squared x. And then I'm going to use the fact that secant squared x equals tangent squared x plus 1. So again, using the Pythagorean. So I'm going to put this in here for here. So now I have cotangent squared x plus 1 minus tangent squared x minus 1, because I'm taking that negative, put into both of those terms, equals cotangent squared x minus tangent squared x. Hopefully you got that right, because since this negative right here, that negative distributes through, so it's tangent, and it distributes through here. So algebra, folks, algebra. So that leaves me with cotangent squared x, 1 minus 1, that cancels out, minus, oops, I meant to do black, minus tangent squared x equals cotangent squared x minus tangent squared x. Okay, box around it. Okay, let's come over here. Okay, so I'm going to consider this the more complex side. So I'm going to make it look like this side. And on this side, I have it in terms of cosine. And so I'm going to turn all the secants in terms of cosine. So I'm going to rewrite this whole thing to be 1 minus 1 over cosine x over 1 minus cosine x equals cosine x minus 1. Okay, now that just means to solve this, I'm going to, you don't have to necessarily show this step, but 1 minus 1 over cosine x. That whole thing is going to be multiplied. I'm going to multiply this by cosine x, kind of, and basically multiply all of this by cosine x. Basically, I'm dividing by the reciprocal, so I'm multiplying it by cosine x. A lot of different ways of saying the same thing. Okay, so this is cosine x, distribute that in, cosine x, distribute that in, minus 1 equals cosine x minus 1. All right, pretty straightforward, pretty simple. Again, the only problem people are going to have is the algebra, I think. I'm afraid of people not distributing it correctly. And then again, the first step is always the hardest. You have to just look at the two problems you have and say, okay, this definitely seems like the more complex one, so I want it to make that look like this. And then recognize the fact that, okay, these are all in terms of secant, but what I'm trying to make it look like is in terms of cosine. So right away, I should be thinking about the fact that cosine x equals, or that secant x equals 1 over cosine x. All right, so just got to get that frame of mind. I know that that first step is what people are struggling with the most. Okay, let's keep going here for a minute. Oh, I only got about 5 minutes. I got to go. Let's go. Let's use do. We're going to make this side look like that side. Just because it has a +1. Anytime you have a +1, that's the side. This is the side we're going to make it look like. So let's use the fact that secant squared, this would be secant squared would be cosine, right? So this would be 1 cosine squared x times sine squared x. So this is negative sine squared x over cosine squared x equals negative secant squared plus 1. This would be negative tangent squared x equals negative secant plus 1 x plus 1. And negative tangent squared x, that's going to equal negative secant squared x plus 1. And you can either trust me on it or look at your Pythagorean identity. I don't have them written out right now, so that equals that. Yeah. Okay. 6, then I gotta stop, I gotta go. Okay, well, obviously, oops, we're gonna work on this side to make it look like that side. So, since I have 1 minus cosecant, I'm thinking Pythagorean. Because of this, I'm thinking Pythagorean. So let's go cosine squared x and 1, let's see, cotangent squared x plus 1 equals cosecant squared x. So I have 1 minus, so cotangent squared x. Well, let's see. We'd actually bring them. We'd kind of take this over here and this over here, and that would give you negative cosecant squared x plus 1 equals negative cotangent squared x. This is the same as 1 minus cosecant squared x. So negative cotangent squared x. So basically what I'm saying is that this equation right here, 1 minus cosecant squared x, equals negative cotangent x. So negative cotangent squared x. The fact that this sine squared is negative is kind of like your little clue that we're going to have this negative here. Okay, so this is cosine squared x times cosine squared x divided by negative cosine squared x over sine squared x equals negative sine squared x. So this is going to be cosine squared x times negative sine squared x over cosine squared x equals negative sine squared x. These cancel out, and it leaves me with negative sine squared x equals negative sine squared x. Okay,